In this video, I'm going to prove that the sum of two odd integers is an even integer. So I'm going to say let m and n be odd integers, okay? So what does an odd integer look like? Well, what an odd integer is that this is going to be equal to some number times 2 plus 1. So let's kind of like write that out. So this means that m is equal to 2 times some number k plus 1, and n is equal to 2 times some number I'm going to call L plus 1, where L comma K are elements of the integers. So L and K can be any number from negative infinity to positive infinity on the whole numbers. So it could be 30 and 7. It could be 12 and 24. It could be negative, both positive, but it doesn't matter. We don't care what they are. But I want to make a note here. Do you notice that I chose two different numbers, or two different letters, K and L? The reason we have to say that is because we don't know that they're the same number. They could be the same. L and K could both equal 3. But we don't know if they do, and for this proof to work, we have to assume that they're not going to be the same. So we're going to keep it arbitrary, you have to assume they're not the same, okay? So that's why we're using two different letters. So now it says sum, so sum just means plus. So let's just add m and m. So n plus m, it doesn't matter what order I add them in because addition is commutative. So n plus m is equal to m plus n, and that's equal to, well, what does m equal? Well, m equals 2k plus 1, and n is equal to, well, n is 2l plus 1, so 2l plus 1, okay? Well, since this is just addition and there's no like multiplication going on, I can actually get rid of all the parentheses. So what I get is 2k, whoops, I want to get rid of parentheses, I don't want them anymore. 2k plus 1 plus 2l plus 1, okay? Now I'm going to start grouping things together. I'm going to add my ones together. So I have 2k plus 2l plus 1. Or whoops, not 1 plus 1 is not 1, it is 2. Okay, so now we're here. We have this line. And now they all have a 2 out front. There's a 2 there, a 2 there, and 2 there. So what I can do is actually factor out a 2. So I'm going to do that. I'm going to go, this is equal to 2 times, well, what do I get left over? Well, since I factored out a 2, I have a k inside. I factored out a 2, I have an L. And then 2 divided by 2 is just, well, that's just 1. So now I have 2 times k plus L plus 1. But if you notice, this is 2 times some number. I know that this piece on the inside right here, that this piece is just going to be an integer. I don't know what integer, but it's going to be a integer, okay? And 2 times any number or any integer is going to be even. So this means that 2 times k plus 1, whoops, let's just write it this way. That just means that that this is even. So then this implies that 2 times k plus L plus 1 is equal to some even number. And you could say by definition of even numbers. And then you're done. The proof is over. Okay? If you have any questions about this proof, please comment below. If you would like me to tackle any proofs that you would like to see done, please comment them below, and I will try my best. Please subscribe if you like this kind of content. Thank you guys for watching.